just thought, well, it's that time of year to start thinking about wave flying around here. Hollister in the Bay Area. And so, really my focus in this talk is for people who've done little or no wave flying and want to know about the opportunities to fly wave out of Hollister, and sort of break it down into things like, what do you look for in terms of weather patterns? What kind of wave will that produce? How do you get into the wave? How do you fly the wave? And then a little bit of the particular weather forecasting tools that I use for that. First thing, just the most basic stuff about wave. Wave lift, the best way that I've found to start visualizing wave lift is think about, you've seen water in a river or a stream that goes over a rock or a log, like a disturbance, and it goes over that disturbance, and it goes down, and it comes back up, and there's a set of these stationary waves that form in the stream because of that disturbance. Goes and bounces, comes back up. And the same thing happens in the atmosphere. When the wind goes over a ridge line or a disturbance, it'll come down the backside and then get this bouncing effect going on. And in the atmosphere, that wave effect just keeps on going up if the right conditions occur. And the most basic thing you want is a substantial wind perpendicular or nearly perpendicular to a ridge line. The wind parallel to the ridge line is not going to get that effect. The wind velocity needs to increase with altitude. If it drops off with altitude, the wave's going to stop. It's not going to happen again. It needs to have that effect. If it just stays the same with altitude for a while, the wave is going to be weaker. The ideal is just a gradual increase with altitude. The minimum to get good wave is maybe 18 or 20 knots perpendicular to the ridge line at ridgetop level, and then increasing as you go higher. And then the other thing you want is stable atmosphere, at least at the ridgetop level. And stable means, well, let's contrast it to unstable. Air that you get good thermal lift in is unstable, in the sense that the temperature profile gets cooler as you go aloft, so if you warm up a piece of parcel of air, it can be buoyant and keep going up. Stable air is where the air, as you get higher, either warms up or does not cool off very much. So if you make a parcel of warm air, it's not very buoyant, it's not going to go up and cool off. If you've got a lot of unstable air that produces strong thermals, they can go up into that wave layer and just disturb it so much that it disorganizes the wave. And for reasons that are not entirely apparent to me yet, I've been told that the best is sort of an inversion layer or stable layer near ridgetop height, unstable below and unstable above, and you get this spring effect. But we'll look at a forecast atmospheric sounding. You can sort of get a look at some of the temperature profiles. The other thing, I should have brought in a chart so I can draw pictures of stuff. So we've got, in the Bay Area, we've got these ridge lines that run northwest to southeast, courtesy of all our fault systems. We've got, here's Hollister, we've got the Santa Cruz Mountains, we've got the mountains over here, the ridge line just east of Hollister. We've got the Gavilan Range, ending up at Fremont Peak up here, and the Sierra de Salinas and other things on the other side of Salinas Valley. And so the wind to be particularly ridges either has to be coming out of sort of the south-southwest or the north-northeast. And so there's two types of weather phenomena that cause that. The south-southwest wind is what we get when a storm front is coming in. And we call it prefrontal wave. And that's what we've seen this week, is a low pressure center is up here, up near the Oregon coast or Eureka or something, and cold fronts coming along, and as a cold front is sweeping through, the strongest wind is usually just before the cold front. It comes parallel to the front, and therefore out of the south and southwest, and kicks off wave off of Fremont Peak and some of these other ridge lines. For Hollister pilots, it's an ideal location to have that wave kicking off of Fremont Peak because it's only about 5 or 8 miles upwind of the airport, and it's upwind. So you can just tow into the wind and see if you can catch wave there. And if it doesn't work, or if when it's time to leave the wave, you can just run back to Hollister. And there are days when very strong waves have been there, and Miguel some years ago was flying the 134 and caught wave on that kind of day, and just basically, well, you just sort of stayed more or less stationary over the airport and went up, right?
Thereabouts. The 18,000 foot was closer to the ridge line.
A little closer.
Towards the motorcycle park in Fremont Peak on Adaria.
As you get in there.
Gap,
Yeah.
like where that quarry is, and went straight up.
And that's, you know, what you get is, again, the wave comes over here, and there's what we call the primary wave, and then the secondary wave, and the tertiary, and you can get wave bars going many times downwind. And the primary is usually the strongest, and the secondary is a little weaker, and the tertiary. So a lot of times when you get into wave, you might get into the third or the second bar and start to climb, and then if you go upwind, you'll go through a sink area, you go into the primary, and that's where it's the strongest, and that's that first one close to the ridgeline. Sometimes it's remarkably close to the ridgeline, and I've also seen a tendency of, as you go higher, the position of the wave actually sort of leans upwind. And you find that when you first got into the wave down low, you were at one point, and when you're 5,000 feet higher, it might be several miles upwind of that is the best point. And it may lean to where you're almost looking down on top of the ridge, usually itself. The problem with this prefrontal wave is it's associated with a storm arriving. And that storm arriving has clouds and rain. And so, you know, I've seen these days where there's good wave, and either there's just, by the time the good wind arrives, it's already raining, or there's just a narrow window of 3 or 4 hours between the time the wave starts and the rain starts, and the clouds get just too thick to fly. And another problem with that is a good part of it is it produces lenticular clouds that mark where the wave is. And I'll show you, I was showing that video of this is a video of a lenticular cloud over Reno, where this is looking south over downtown Reno, and here's Mount Rose is over here and Slide Mountain. So the wind is coming over the Mount Rose mountain range, and it comes down and then it bounces up and it makes this wave bar. And you see these little bits of cloud forming down here. These are little bits of thermal that come up, form a little cumulus, and the wind is blowing so hard they're just scattered down. We call that, those are rotor clouds, where there is, underneath the wave, there's often this very violent turbulence, rotor turbulence. But, you know, that's just a classic lenticular cloud. And what that's telling you is if you fly under this in the glider, right about here is where your strongest wave should be, right under the leading edge of lenticular. And this one's very high, but you may, around here, there might have been lenticulars at 5,000 or 6,000 feet the last few days. So if there's a big enough blue gap, you end up climbing in front of that lenticular and above the lenticular. And there's several hazards that come with that. One is you're up there having this great time in wave at 12,000 feet, looking down, looking at everything around you, and then you look down and the wave gap is closing and closing and closing and filling in with cloud. And you can get trapped on top of the wave. Fortunately,
it can happen very quickly.
And it can happen very quickly, yes. It can fill in remarkably fast. If that happens to you over Hollister, a lot of times, if you look 20 miles downwind, out past Los Banos Reservoir, out towards the Central Valley, it's dried out, and the cloud deck is not solid out there. And so the safe thing to do in that is not to attempt to penetrate down through that cloud, but to run downwind and go land at a safe airport and get a ground retrieve. that's just, think of that as you're out. People talk about whether your glider can do a benign spiral mode or something like that and spiral down through it. But, if you've got the ability to fly VFR to an airport, do that. I mean, you're up there and the wave is happening because it's blowing 30 or 40 knots, and it's going to blow you downwind to an airport. Take advantage of that. The other thing that can happen is sometimes these lenticulars, instead of just being a discrete layer, they just keep going up and up and up. And it looks like a loaf of bread or something. And it goes for thousands of feet. And you're trying to climb in front of that, and the gap closes. And this has happened to several people in the Reno area where they were flying wave, where they were either trying to cut through a gap or they thought they were in front of the lenticular, and either they backed up a little bit or the gap just filled in and all of a sudden they were in cloud. And these were a couple of very experienced pilots who destroyed gliders this way. One of them was, the most recent was Bob Spielman, who parachuted out and landed on the roof of a parking garage attached to a hospital in downtown Reno. And some years earlier, there was another fellow who found himself landing by parachute out in Sparks, Nevada, and got dragged on the ground a little bit, beat up a little bit. So on these prefrontal wave days where there's enough moisture to make these lenticulars, that's great, but you have to be very conscious of this danger that can come with it. So, if you're trying to figure out, well, when is this going to happen around here, it's when the weather forecast, the best days was when the weather forecast says, oh, a cold front's coming through with strong winds, but it's relatively dry. We don't expect, we expect rain in Marin, but no rain down in the Monterey Bay Area. And I don't know how many people are familiar with looking at the area forecast discussion from the National Weather Service. If you go to, what I'm going to do is, I've got references to these various weather sources on this handout, and I'll send an email around with this handout afterwards so you can see this. But on the National Weather Service forecast page, there's this little link called AFD, and it's basically the meteorologists explaining to other meteorologists or people who are interested how they came to their conclusions about the forecast. And a lot of jargon in there. It takes a while, it takes a few tries to sort of start making sense out of their jargon. But what you get out of that, just in terms of general forecasting, you get their confidence level. Like a lot of times they'll say, you'll be looking at a forecast 5 days in the future that says chance of showers or something, or chance of rain. And they'll say, sometimes it'll say, all three weather models say showery conditions that day. So there's high confidence it's just going to be showery. Other times it might be that one weather model says it's going to be blue skies, the other weather model says it's going to rain an inch. And so they say showery conditions is their compromise because it's 5 days out and they don't know. But the other thing is that they will talk about these wind events and things like this. And for example, so this was on Sunday afternoon, I looked up the area forecast discussion, and here's your jargon. Synoptically, a long way of trough will set up. But it goes down here and it's talking about Thursday and Friday, periods of moderate to heavy rain are possible. Rainfall amounts very tricky due to uncertainty. Southerly winds will be on the increase for Thursday and Friday as the gradient tightens. Higher elevation spots could see gusts well over 30 miles per hour. So when he's talking about the gradient, he means the pressure gradient, if you were to look at a pressure weather map. So that's, for me, a clue that they were at that time on Sunday forecasting strong winds associated with the front late this week. Now, that was the forecast on Sunday. When I looked at it again today, it's backed off on the wind forecast for Thursday and Friday and up the forecast for rain. So it became less. But that's one of the sources. So that's sort of the pattern that brings this. It's winter storm fronts, especially ones where the Weather Service is forecasting a lot of wind. But the ideal one is where they're saying a lot of wind without a lot of cloud and rain. So the other type of wave we get around here, and the one that probably I've had the most fun with is what we call post-frontal wave. And this will happen not always after a storm goes through, but sometimes after a storm goes through, especially if the low pressure center goes down below. So you know, the low pressure center of the air is going counterclockwise, and high pressure center's air goes clockwise. If the low pressure center goes down south of us and a high pressure center goes in here, you can get the two of them bringing strong winds out of the north and northeast. And so the wind is coming across the mountains from the other side and kicking off wave on the other side of the same mountain ranges. And in particular, when you're flying out of Hollister, sometimes you can catch the wave just upwind of Hollister around the Casa de Fruta area, over here, Pacheco Pass. I mean, I had a day some years ago when I towed up near Henrietta, and it was not a great wave day. I could stay between 4,000 and 5,000 feet for 2 hours, just running just downwind of the ridges north of Henrietta. And the wind was calm back in Mountain View where I lived at the time. There was a little bit of east wind on the ground at Hollister, and I just, sort of gave it a try, and there it was. But what I found on these really strong days, the best place has been to go over towards Watsonville and catch the wave off of the Santa Cruz Mountains. And I don't know how many people are familiar don't normally fly gliders towards Watsonville from Hollister unless you're flying on a ride or something. But just a little west of Highway 101, next to Highway 129 that goes over towards Watsonville, is a giant gravel pit, the Aromas Quarry, granite rock. And I've caught the wave sort of over that or just a little bit northwest of that on these north wind wave days. So on these north wind days, generally it's going to be dry, and you're not going to get lenticular clouds. I don't think I've seen those. I've seen a little bit of rotor cumulus clouds forming. On the prefrontal wave days, you could probably launch out of Hollister and head over towards Pinoche and catch wave. And on those days, I've watched the progression of the wave on the satellite photos, and you'll see these beautiful lenticulars. And then they move a little further south, and the solid cloud moves in, and then they move a little further south, and you could go down to Avenue, you could go all the way to Southern California in the prefrontal wave. You do those kinds of things.
But you can't come back.
You can't come back. So, in terms of flying in wave, getting into the wave, I have not really had luck thermaling into the wave. Out of Hollister. I'll do that. I've done that a fair amount up in the Sierras and flying out of Minden and Air Sail. So when you thermal into the wave, here's this mountain. It's making here, and it comes up again. And what will happen is when there's wave aloft, it actually will induce the thermals to come up right under the wave, up part of the wave. The wave will organize the thermals. They're often very rough thermals. And I think the first time I really got into good wave up in Minden, it was one of those things where we were in this thermal and going around and going up 60% of the time and down 40%. And then you get higher and it gets a little better. It's 2/3 up, and then it's 3/4 up. And then it gets to where it's rough on the downwind side of the circle and it's smooth on the upwind side of the circle. And when you get to that point, just turn upwind and you're in the wave. And up you go. But here, it's been more tow into the wave. If it's the prefrontal wave, you tow to the area downwind of Fremont Peak. If it's the north wind wave, I've often towed over towards Watsonville. And what I've had to do was, I tow to like 4,000 or 5,000 feet and just commit to, if this doesn't work, I'm landing at Watsonville and getting the tow back. Get into the wave. I've probably caught it as low as 3,500 or 4,000. And then finally, over the Watsonville Airport, I started to hit a little bit of lift. And work it back and forth, and at least I'm not losing anymore. And so in wave, the wave bar stays in one place, so you need to work that one spot and go back and forth across the wave. And then I went upwind, and it got a little better. I gained a little bit more altitude. And now you can see the way the glider is crabbing across the wind because you're flying with a 30 or 40 knot wind. And then the further I go upwind, the better it gets. This is probably the secondary wave here.
So it's a pretty short band.
At this point it was. Sometimes the bands are very short, sometimes they're quite long. So now I'm in the down part going towards the primary, and then I hit the primary and it's much stronger here. And now it really starts going up.
Notice where he is relative to the ridge line. You look down, and at that point it might seem like it's almost right below you.
Yeah, it looks that way to you because when you're, let's see if we get that view. When you're at this altitude, you're looking down like this at the ridge line. It's really pretty close there.
Right by Loma Prieta, or where is that?
Yeah, that's Loma Prieta. So here's Highway 17 in Lexington Reservoir.
Yeah.
And that's where it was really strong, just down in the Loma Prieta there. Yeah, you can see how strongly it climbed in that area.
What's that altitude now?
15, going through 16. We have a rule in BASA to protect the gel coat on the DGs that we don't want you flying below -10 Celsius. So pay attention to the outside air temperature gauge. In the Bay Area, on the fringes of the Bay Area, you want to have a working transponder to do this stuff. And for example, I don't think I would do this flight without a working transponder because the approach path for airliners coming to San Francisco from the south.
They're coming in at 5,000 feet right there at the reservoir.
Yeah.
6,000.
So they're basically under you here. I mean, they cross over Capitola at about 10 to 15. So I talked about, one of the things I watch is I read these area forecasts because I just watch the general, hey, it's stormy weather. That means something like this is coming. And then if it's, for the north wind wave, I'm reading this and they're saying if they're predicting a north, strong northerly winds in the days after the front comes through. So one of the tools you can use, there's a product that I don't think enough people look at, called the wind dip forecast that Dr. Jack still creates, that gives you forecast winds at 850 millibar and 300 millibar for a given location. He's got them for the Reno area, for Salinas, I think there's one up the Williams area, and got it for different weather models. And so 850 millibars is about 5,000 feet, so that's about our ridgetop level. And 300 millibars is about 30,000 feet. And Doug Armstrong, who passed away a few years ago, was a meteorologist up in Reno who did a lot of forecasting for glider pilots. He sort of had a rule of thumb that said, if you got 20 knots perpendicular to the ridge at ridgetop level, and 60 knots up at 30,000 feet, you're probably gonna have good wave. And so what this does is just gives you a snapshot to look at some day out here. So this was the forecast I pulled up on Sunday, and the 25th early morning, so that was yesterday early morning, it was forecasting at Salinas 22 knots from 204 at ridgetop level, 92 knots from 263 as you got higher. That's the kind of thing that gets my attention. That's saying, showing that there's a good chance of wind for wave. So that's one of the things you can get that gives you a chance to look, half a week ahead of what the forecast wind speeds are. Another one, windytie.com is an interesting one for wind forecasts and weather forecasts in general. It's windyty.com. Another tool that's good for both forecasting thermal soaring and wave soaring is forecast soundings. And what we've got now is you've got these computerized weather models that are basically predicting what you would see if you released a balloon over a different point on the ground. And so you can get these forecast soundings of what the weather model thinks you would find. And so Kurt Thames created a web page, and it'll be in this, I'll give you a link to this, where you can, it's got a Google Maps interface. You can go to where you want and you select the weather model and the time frame, and it will grab the available plots from the forecast. And so it's got these wind barbs showing speed and direction. And direction is true, I think, true degrees, true north. They're all on top of each other down here, but this little blue line is a plot of wind speed, 0, 50 knots, 100 knots. So you can sort of follow this up, and you see at 5,000 feet, it's showing about 30 knots of wind. And then the wind speed doesn't increase a whole lot until you get up to about 16,000, and then it gets better again. So this here is not, you know, it would be best if the wind speed just had a steady increase, things like that. And then as you get within a couple of days of the wave, you can use the RASP blip maps. And the main blip maps, the large-scale blip maps for all of California and Nevada, do not have a wave forecast map. It is called a vertical velocity map, and they have them at 850 millibars, 700 millibars, and 500. So that's 5,000 feet, 10,000 feet, 18,000 feet. And so it's showing the wind barbs, and where it shows red and orange, it's forecasting updraft, and where it's showing green and blue, it's forecasting downdraft. You know, it's just showing you whether it forecasts that some wave is going to happen, and where you're likely to find it. Obviously, these are only forecasts, and just a slight change in wind direction or wind speed can cause that wave to be in a different place. I don't know that any of us really tried to find wave over near Watsonville before we had these RASP maps. And we started looking at these things and going, it says there's going to be wave over there. This has worked up at Truckee. This has worked at Air Sailing. It should work here. Well, let's go look. And we started finding the wave over there. Now, at this large scale, this is the 3 kilometer scale, it's very crude. It doesn't really show you the individual wave bands very well, but it shows you the regions where wave is likely to be. Another great weather forecasting tool is subscribe to the HGC Yahoo group, which is HGC group, which is pilots who fly out of Hollister, put emails on there, and boast about the flights they had, but also when Matt Gillis and Darren Braun and these other guys who are looking at the weather all the time see a weather event coming, that's where they'll post about it. And so they do the weather forecasting for you. It's great.
Thank you very much.
Thank you very much.